we're looking at here, describe the ionizing properties of an alpha particle, beta particle, and gamma radiation. Now, when we're talking about ionization, what are we actually talking about? What is, and for instance, firstly, what is an ion? It's a charged particle. It's any particle that's got some sort of charge on it. So you can get a molecule that's got a charge on, you can get an atom. So if I've got, for instance, X plus like that, that means that I have got more protons than electrons. If I've got X minus, it means that I've got more electrons than protons. This we call a what? What do we call the positive? Cation. Physics students chemistry students, you do this more. And a negative one is an anion. So that's your negative ion. Now, the thing with this is that as these particles, as these alpha particles and beta particles travel through material, they have an ionizing effect. And that means, ionizing properties means that they create ions as they go through. So they are creating ions in materials that they are passing through. So we're looking at what are the ionizing properties of an alpha particle, a beta particle, and a gamma radiation. Now, I would suggest that you take this table from the PowerPoint and you just print it out here. Alright, and you put it as part of your notes. It's got all the different properties of your three different types. Now, I don't know how you are with diagrams and so forth, but I would learn much better from this than my own notes perhaps. But the thing is you do have to get this information into your own heads. Alright, now you do get your notes with you for these tests that you write this year. Next year that will change. But so this does have to go into your brains. Now, this is what we're looking at over here, the ionizing effect. Now, with alpha particles, it's very strong. Alright? Beta particles, it's weak or weaker. And with gamma rays, it's very weak. Now, the reason for it being really strong with an alpha particle is firstly, it's got 2 protons. Alright, so the charge is much bigger. So obviously when you talk about ions, you've got this particle that's going through, and what's happening is that it's causing electrons to be attracted towards those positive, and it's ripping them off as it's going along. So it causes a large amount of ionizing. It's also big. Alright? It's because it's bigger, it's got more charge, it's got double the charge of a beta ray, it's strong. The beta particle does cause ionization, but it's a bit weaker. It's obviously -1 is the charge. Your gamma ray is not doesn't have a lot of ionizing effect. It's very weak because it generally doesn't interact very much. It just goes straight through. Now, what's important also is this idea of the penetrating effect. And this has got a great importance because if you are wanting to protect yourself from, for instance, some sort of radioactive decay process, and you have got an alpha particle, it's not difficult to protect yourself. You just get some paper and you protect yourself. All right. Thick piece of paper, generally all right. All right. Alright, I just knocked off that alpha particle there. Alright. When you're looking at beta particle, it's quite easy. It says a few millimeters of aluminium or other metal will protect yourself. So, alright, you can protect yourself with a bit of metal. But when you're talking about gamma radiation, this is very difficult. So, if there's gamma radiation, for instance, a nuclear power plant being given off, they put lots of concrete, lead, and they try and absorb it, but it doesn't all get absorbed. And so this can be a real problem. that your gamma radiation is a lot. I mean, obviously, when you are dealing with in medical physics, if any of you get involved in that, it's a huge field in that medical physics, because they're designing more and more machines that try and target or get rid of specific cells and so forth, and they use these rays, these high energy rays, to try and knock them out, to destroy them. People working in those areas have to be careful. So they will, for instance, wear a tag that will pick up the amount of radiation that they've been exposed to. They will try and measure that up. They say that if you regularly go to the dentist and get X-rays, that you've got a higher chance of getting brain cancer over a period of time. So, next time you go, maybe just say to your dentist, I'd prefer this time not to have an X-ray, maybe every 2 years have an X-ray. Sometimes you're given these things for not all that good a reason. All right, yes. No. Data booklet, yes. I'll give you a new one. All right, and then there's one further thing that I want to get through. When these particles, when these alpha and beta particles go through a magnetic field, they will get affected. You can actually move them about. So, for instance, when I have an alpha particle going through a magnetic field, it's a positive charge. Fingers, right hand in the direction of the magnetic field, the thumb in the direction of the particle, in this case alpha particle in that direction, the force will be up, and that's why you've got this would be going slightly upwards, like that. Beta particle, now north to south, but now it's a negative charge, so the thumb goes in the opposite direction. Alright, so it's like that. Palm going down, it bends. Now why is the beta particle bending much more than the alpha particle? That's right, your alpha particle is hugely much more bigger. It's like about 40,000, so there's about a 10,000 difference. So it's about a 40,000 difference. So you can imagine a truck going along the road, alright, a car hits into it. Alright, notice it. That's a bad mistake from you. Alright? Alright, truck doesn't get affected. A car comes down the road and somebody on a scooter goes along, gets hit by the car. Big problem, alright? Less mass, big problem, more effect. So you get this situation over here with your beta particle is going to be much more affected due to that force, due to the less mass that we have.